Disclaimer: this episode is produced as a partnership with HanamiMastery. Check out our companion episode featured on their website. I wrote a small to-do app that uses Ruby, Roda, and a small Ruby framework I'm writing. It works well for what it does. It needs to access a database object in order to load, save, or destroy tasks. This means that this database object is passed into many other objects. For example, the main object, the to-do app, and the task list. Also, we need to instantiate it on the main Roda file and the specs. The same happens with the main to-do app object, which needs to be present in both places. Due to this, we need to control the creation and maintenance of the instances, which is something we don't want to take care of. Let's run all the specs I used to drive the design of this application to show they are passing. In order to solve our dependencies hell, we are going to implement the registry pattern. The definition of the registry pattern that resonates with me the most comes from the C2 wiki, which states, "A registry is a global association from keys to objects, allowing the objects to be reached from anywhere." So we need to implement a centralized registry to keep global objects at hand. Let's create a registry class with a load class method that creates an instance and memoizes it. Then we create a private initializer. I've been using this pattern in my projects because it allows me to very easily implement subclasses of my classes and load them from this instance creation method. We can talk about this in another episode. Now that we know how to load the registry, let's assign it to a constant at the bottom of the file. This way, when the file is loaded, the main registry will be created. I'm not arguing this is the best or the only way to do this. It's just the way I'm implementing it in this example. We now need a way to register objects with a key. Let's write some implementation code. One way we can approach this is to write a register method for our instance. But there's a better Ruby idiom to write this, using the square brackets. And now that we've chosen this idiom, let's also register the to-do app. To implement this, we first assign an empty hash to an instance variable we will call registered objects. Then we define the square brackets equal method, and we implement it by assigning it to the hash. We'll also raise an error if the key has already been registered. We will also need a method to retrieve these objects. We could call it retrieve or get, but I prefer to be consistent and use the square brackets idiom again. And to retrieve it, we can use the fetch method from the hash instance. Now that we have implemented the pattern, let's propagate it throughout our application. The first place we'll remove it from is the to-do app class. We first remove it from the load method and the initializer, and next we retrieve the DB instance variable from the database we get from our registry. Now that we made this change, we can retrieve it on the web application and the spec files, and run our specs to see if they still work. Next, we can do the same with the to-do app. We'll retrieve it on the web application and on the specs, and run the specs. We can also test this working on the web application, which it does. Now that we have our registry, we can add a third key very easily. For example, let's add a logger. Now we can, for example, log every time we enter a route. And we can add a route to display the logger messages. And now, when we use our app and check out the logger messages, we can see that they are all there. We could simplify all this work by using the dry system gem, or by creating our project with Hanami, which already uses it. You can understand how to do it by visiting the companion episode we've written on HanamiMastery. In that episode, we are going to talk about how Hanami uses dry system to implement the registry pattern and how to use it. Don't miss it. The registry pattern allows us to have access to all our configured components without having to carry their configuration and setup logic around. Also, it can help in specs by allowing us to change the implementation of specific components, eliminating the need to mock methods on constants. And it reduces the number of objects created on our application. On the other hand, one disadvantage of this pattern is that we end up with a global object which is not recommended to have. I hope you liked this episode, and I'll see you on the next one. Oh, and don't forget to visit our friends at HanamiMastery and give them our love. Bye!